Hello everyone, this is Maisha Ali from second year Computer Science Department, and today I am here to talk about two very famous protocols, RIP and OSPF. Let us begin with RIP. Routing Information Protocol is a dynamic Layer 3 routing protocol that belongs to the distance vector category. It is one of the oldest routing protocols designed to exchange routing information within an autonomous system. Key features of RIP. Number 1. It is a distance vector protocol, which means that routers send their entire routing table to their neighbors. Each router learns about the network topology from the distance, which means the number of hops to each destination. How RIP works is that it has a hop count limit. It uses a hop count as the metric for choosing the best path with a maximum of 15 hops. So, a destination more than 15 hops away is considered unreachable. Number 3. Periodic updates. RIP routers broadcast their entire routing table every 30 seconds to their neighbors to maintain up-to-date routing information. 4. Routing loops prevention. RIP uses techniques like split horizon, route poisoning, and hold down timers to prevent routing loops and ensure the network converges correctly. Number 5, and also one of the most important points of RIP, is that it is very simple to configure. And it doesn't require complex setup compared to other complex protocols like OSPF or EIGRP. Let us talk about the kind of IP addresses it supports. RIP supports both IPv4 and IPv6. The process of how packets are exchanged. Number 1. Neighbor discovery. RIP routers periodically broadcast routing updates to all of their neighbors. These updates contain the full routing table, and routers use this information to adjust their own routing table. These updates are sent every 30 seconds, allowing routers to exchange information about reachable networks. As I had mentioned before, if any network crosses the 15 hop count limit, then it is considered unreachable and no information can be sent. Number 3. Route calculation. RIP calculates the best route to a destination based on the hop count. If a new route with fewer hops is learned, it replaces the old route. 4. Convergence. RIP takes longer to converge because it uses periodic updates and relies on broadcast mechanisms. If there is a change in the network, example, a router failure, it may take some time for RIP to adapt. Now, let us look at the advantages and disadvantages of this protocol. The main advantages include that it is simple and easy to configure. It is easy to set up and manage, which makes it very ideal for the smaller networks to use. It is a very straightforward routing protocol. Number 2 is that it is widely supported. It is supported by most routers and network devices, ensuring its broad compatibility across different vendors and equipment. Number 3, there is no need for complex configuration. Now, we will discuss the disadvantages of RIP. Its limited scalability. RIP's hop count limit of 15 hops restricts its use in large or geographical dispersed networks. Number 2, slow convergence. RIP's periodic updates and slow convergence time mean it is not ideal for networks that require quick adaptation to changes. An important point to note is that it is very inefficient in large networks. Because its maximum limit is just to 15 hops, it cannot work for large networks with complex topologies. And it also relies on broadcast updates and simple distance vector approach, which can lead to inefficiencies in routing and bandwidth consumption. Now, let us talk about the second protocol, OSPF, which stands for Open Shortest Path First. It is also a dynamic Layer 3 routing protocol that belongs to the link state category. It is used to exchange routing information with an autonomous system and uses the Dijkstra algorithm to calculate the best possible path to each destination in the network. What are some of the most important features of OSPF? Let us have a look. Number 1, as I mentioned, it is a link state protocol, which means that each router maintains a link state database that is shared with other routers using link state advertisements, also known as hello packets. This allows routers to have a complete view of the entire network topology. Number 2, the algorithm it uses, Dijkstra, which is also known as the shortest path first algorithm. Once the routers have all the link state information, OSPF uses the Dijkstra algorithm to calculate the shortest and the most efficient path to each destination. Number 3, unlike RIP, the main difference of OSPF is that it has no hop count limitation. It has no limit of 15 or any hop count limitation because that is not even the metric that OSPF uses to calculate the distance from one network to the other. It uses a cost as the metric, which is based on the bandwidth of the links. The lower the cost, the more preferred the path is. This allows more flexibility and efficient routing based on link quality. Hierarchical design. OSPF divides the network into areas with a backbone area called as Area 0 connecting all the other areas. This improves scalability and reduces the size of the routing table in each router. What kind of IP addresses does OSPF support? OSPF supports IPv6, which means the 6th version of the IP addresses, making it suitable for modern network environments. As we all know, instead of IPv4, most computers and systems that we use nowadays use IPv6. Authentication. OSPF can be configured with authentication to prevent unauthorized routers from participating in the OSPF domain, adding security to the network. Now, let us discuss the process of how the packets are exchanged in OSPF. Number 1, neighbor discovery. Like I had said, it uses link state advertisements, which are hello packets. So these OSPF routers exchange hello packets to discover other OSPF routers on the same network, which is the same autonomous system. They verify compatibility, such as matching hello and dead intervals in area IDs. LSA exchange. After discovering neighbors, routers exchange link state advertisements to share information about their links and network topology. SPF calculation, which basically means using the Dijkstra algorithm to calculate the shortest path so that you can use the shortest path as the first path to travel from network A to network B. 4. Updating the routing table. After the SPF algorithm completes, each router updates its routing table with the best paths. Number 5. Periodic hello packets. OSPF routers periodically send hello packets to maintain their neighbor relationships and detect failures. Let's say you are sending a packet from network A to network B. If you don't receive that packet in a certain amount of time, that packet is considered lost or unreachable, which can detect a failure. So, link state advertisements, also known as hello packets, can be used for this network failure detection. If a router does not receive hello packets from a neighbor, it is considered that the neighbor has gone down. Let us talk about the OSPF areas and the area IDs. Area 0, the most important backbone area. It is the central area of an OSPF network connecting all the other areas. So, all OSPF areas must be connected to this area 0. Non-backbone areas. These are the areas that are connected to area 0 and help segment the network to improve scalability and performance. This is how the connection is formed. All the area IDs is a 32-bit value, which is very similar to the IP addresses used to uniquely identify each OSPF area. Now we have seen the advantages of RIP and the disadvantages of RIP, but we have not seen those for OSPF yet. So advantages of OSPF include, number 1 and the most important point, the scalability. Unlike RIP, OSPF can scale efficiently to large and complex networks by segmenting the network into areas, reducing the size of routing tables and limiting the scope of the hello packets. Number 2, faster convergence. OSPF converges much faster than the distance vector protocol RIP, minimizing downtime and routing loops in dynamic network environments. Number 3, hierarchical routing. The use of areas in OSPF enables hierarchical routing, which helps improve routing efficiency, reduces overhead, and simplifies network management. Number 4, OSPF makes a way better use of the bandwidth. OSPF routers exchange only updates when there are changes in the network topology, reducing unnecessary traffic and conserving the bandwidth. In RIP, what we have seen is that every 30 seconds, packets of paths and the routing information keeps exchanging. Whereas in OSPF, it makes use of the bandwidth in a much better format where it only sends the routing information only when it's necessary. Point number 5, support for multiple metrics. OSPF allows for the use of multiple metrics for routing decisions based on linked bandwidth, providing more flexibility for route optimization. Number 6, security. OSPF supports authentication, providing an added layer of security by ensuring that only trusted routers can participate in this routing network. As we have seen, this is missing in RIP. Although we have seen many advantages of OSPF, there are still quite a few disadvantages. Number 1 is complex configuration. Unlike RIP, OSPF is quite difficult to set up and may not be accepted everywhere because it requires careful planning, especially in larger networks with multiple areas. Number 2, OSPF is resource intensive. Because OSPF builds and maintains a complete link state database, it can be more resource intensive than the distance vector protocols, which require more CPU and memory usage, resources and routers. Number 3, initial overhead. OSPF's initial synchronization and database exchange can lead to higher overhead compared to simpler protocols like RIP. Now, let us have a brief comparison of OSPF and RIP. They are both dynamic routing protocols, but what is different? Their design and their functionality are their main differences. OSPF is a link state protocol using the Dijkstra algorithm for calculating optimal paths and is designed for large and scalable networks. It supports IPv6, uses cost as a metric, and operates with a hierarchical design that divides the network into areas, improving performance and scalability. OSPF converges faster and requires more resources than RIP. Whereas, on the other hand, RIP is a distance vector protocol, which uses hop count as a metric and is suited for smaller network. It has a hop count limit of 15 and converges slower than OSPF, making it less efficient in large or dynamic networks. RIP is simpler and less resource intensive. After looking at the advantages, disadvantages, the functionalities of RIP and OSPF, I think we can come to a conclusion that in short, OSPF is more scalable, efficient and suitable for larger networks, whereas RIP is simpler and better for smaller and less complex networks. Once again, this was Maisha Ali from second year CSE department, and this was my discussion on RIP and OSPF protocols.